Imagine an ocean floor carpeted in purple spines, stretching endlessly beneath waters that once teemed with life. No fish darting between towering kelp forests, no seabirds diving for prey, just thousands of sea urchins methodically devouring the last remnants of what was once one of the world's most vibrant marine ecosystems. This was the reality facing British Columbia's coast by the 1960s. The Pacific waters that had supported indigenous communities for millennia and later sustained commercial fisheries had become ecological wastelands. Marine biologists feared complete collapse. Fishermen returned with empty nets. The silence beneath the waves was deafening. But then came one of the most audacious conservation experiments in Canadian history. What if the very species that had been hunted to near extinction could be the key to bringing the ocean back to life? For thousands of years, the BC coast was home to towering underwater forests of kelp that stretched for miles. These weren't just plants, they were the foundation of an entire ecosystem. Fish sheltered in their fronds, crabs scuttled along their holdfasts, seabirds fed on the abundance they supported. Indigenous peoples had sustainably harvested from these waters for generations, understanding the delicate balance that kept everything in harmony. At the heart of this balance was a small, furry marine mammal, the sea otter. Armed with the densest fur in the animal kingdom and an appetite for sea urchins, these creatures were the invisible guardians of the kelp forests. But the 18th and 19th centuries brought devastating change. Russian and European fur traders discovered that sea otter pelts were worth their weight in gold. The systematic slaughter that followed was relentless. By 1900, sea otters had vanished from most of their range. In British Columbia, they were completely gone. Without their primary predator, sea urchin populations exploded. These spiny grazers began an ecological rampage, consuming kelp faster than it could grow. Entire forests disappeared, leaving behind what scientists grimly called urchin barrens, vast underwater deserts where almost nothing could survive. The cascade of destruction was swift and merciless. Fish populations crashed without shelter and nursery grounds. Coastal erosion increased without kelp to buffer waves. Traditional food sources for indigenous communities vanished. The economic foundation of coastal towns crumbled. By the late 1960s, Canadian scientists faced a stark choice: watch the ecosystem die completely or attempt something unprecedented. Their plan was based on a simple but revolutionary idea that bringing back one key species could trigger the recovery of an entire ecosystem. This concept, known as a trophic cascade, suggests that apex predators shape entire food webs. Remove the predator, and everything below collapses. Restore the predator, and the balance returns. It was elegant, in theory, but had never been tested on this scale. The plan was controversial from the start. Between 1969 and 1972, Canadian officials captured 89 sea otters from healthy Alaskan populations and transported them to Vancouver Island. The logistics were staggering. Specially designed transport tanks, military aircraft, and veterinary teams worked around the clock. Many otters didn't survive the stress of relocation. Others fled immediately upon release. The backlash was immediate and intense. Shellfish harvesters saw their livelihoods threatened. Sea otters consume up to 25% of their body weight daily in clams, crabs, and urchins. Many indigenous communities felt excluded from a decision affecting their traditional territories. Local fishermen watched their urchin harvests disappear overnight. "It's like dropping wolves into a sheep pasture," one harvester complained. Critics called the project reckless, arguing that bureaucrats were sacrificing human communities for an ecological experiment. For years, the project seemed to confirm its critics' worst fears. Otter populations remained small and scattered. Shellfish catches plummeted near release sites. Some areas saw temporary recoveries of urchin populations when otters moved elsewhere. But by the early 1980s, patient observers began noticing subtle changes. In Checklisset Bay, where a small otter population had established itself, the purple carpet of urchins was thinning. In scattered patches, something remarkable was happening. Tiny kelp shoots were emerging from the sea floor. Kelp is one of nature's most explosive growers, capable of reaching 3 feet per day under ideal conditions. Once the urchins were controlled, the kelp seized its opportunity. Within months, underwater forests began rising from areas that had been barren for decades. The transformation was breathtaking. Divers who had explored lifeless rocky plains now swam through cathedral-like groves of swaying kelp. The forest created three-dimensional habitat where life could flourish again. Young salmon found shelter from predators, rockfish established territories, crabs and sea stars returned to the sea floor. As the 1990s progressed, the recovery accelerated beyond anyone's wildest projections. Wherever sea otters established permanent populations, the same miraculous transformation occurred. Urchin populations crashed, kelp forests erupted, and biodiversity exploded. The ecological benefits rippled outward in ways scientists hadn't anticipated. Kelp forests acted as natural breakwaters, reducing coastal erosion. They absorbed carbon dioxide from seawater, helping combat ocean acidification. The dense canopy provided nursery habitat for commercially important fish species. Most remarkably, the system began to self-regulate. Rather than eliminating urchins entirely, sea otters maintained them at sustainable levels. This created a stable balance, enough urchins to fulfill their ecological role, but not enough to destroy the kelp forests. By 2000, the sea otter population had grown from fewer than 100 survivors to over 3,000 individuals. By 2013, that number had doubled again. Each expansion brought new areas back to life, creating a growing network of healthy marine ecosystems along hundreds of kilometers of coastline. The benefits extended far beyond environmental restoration. In 2020, University of British Columbia researchers calculated that healthy sea otter populations contributed an estimated $53 million annually to the regional economy, nearly 8 times the losses experienced by shellfish harvesters. The economic gains came from 3 sources. First, improved fish habitat led to stronger, more stable populations of commercially important species. Second, kelp forests became powerful carbon sinks, storing thousands of tons of carbon dioxide annually. Third, sea otters became a major draw for ecotourism, attracting visitors eager to see these charismatic animals in their natural habitat. Whale-watching companies added otter tours to their offerings. Diving operators marketed kelp forest experiences. Coastal lodges built their brands around wildlife viewing. The same communities that had initially opposed the reintroduction found new economic opportunities in the restored ecosystem. The climate benefits were equally significant. The expanded kelp forests captured carbon at rates comparable to terrestrial forests, while also buffering the coast against rising seas and increasing storm intensity. Today, with over 8,000 sea otters thriving along the BC coast, the recovery stands as one of conservation's greatest success stories. But significant challenges remain. Oil spills pose an existential threat. A single major incident could devastate the population, as the 1989 Exxon Valdez disaster demonstrated in Alaska. Climate change presents new uncertainties. Rising sea temperatures and changing ocean chemistry could affect both kelp growth and otter distribution. Meanwhile, the need for collaborative management with indigenous communities has become increasingly urgent as First Nations assert their rights to co-manage marine resources in their traditional territories. The most important lesson from British Columbia's experience may be the power of patience and persistence. The full transformation took over 3 decades to unfold. Early critics weren't wrong about the short-term costs, but they failed to envision the long-term benefits. The sea otter story offers hope for restoration efforts worldwide. It demonstrates that even severely damaged ecosystems can recover when given the right conditions. The key is understanding which species are most critical to ecosystem function and having the courage to take bold action. From the brink of extinction to ecosystem engineers, sea otters have proven that nature's resilience, when combined with human determination, can achieve what once seemed impossible. Where scientists once feared total collapse, vibrant underwater forests now sway in the currents, supporting thousands of species and millions of dollars in economic activity. The ocean remembers how to heal itself. Sometimes it just needs a little help from its smallest, most unexpected heroes. What began as a desperate gamble has become a living testament to the power of ecological restoration. The sea otters have done their job. The question now is whether we'll have the wisdom to protect what they've rebuilt and the courage to apply these lessons to other ecosystems in crisis around the world.